In this video, we're going to look at how to find the nth degree Taylor polynomial for sine of x centered about 0. Very first thing you do, calculate your function at 0, see what that value is. Sine of 0 is 0. So there's not going to be a constant term on this. That actually makes sense. If you think of the graph of sine x, it goes through 0, 0, so we don't want that vertically shifted. We want to go through 0, 0. So this makes sense in the notion of approximating sine of x. Now we're going to go ahead and find some of our derivatives and evaluate those at 0. So the first derivative is cosine of x, f prime of 0 equals 1. Second derivative, the derivative of cosine is negative sine of x. Evaluating that at 0 is 0. Third derivative is actually going to be a negative cosine of x. The third derivative evaluated at 0 gives us a negative 1. And the fourth derivative of x is, normally the derivative of cosine is negative sine, but we make that negative, so we're going to get a positive sine of x. And the fourth derivative evaluated at 0 is 0. And notice we're back to where we started. This pattern is going to repeat. Right? So let's start to build our polynomial. Now there is no constant term. We'll just call a piece of n of x and we'll just stop somewhere. So the first term we're going to get comes from the first derivative, which means it's getting multiplied by x to the first over 1 factorial. So there's our first degree Taylor polynomial. We're going to get no contribution from the squared term because of the 0. We will get a contribution from the cubed term, the minus x cubed over 3 factorial. No contribution from the fourth term. As you can see with the pattern from the fifth term, we'd get plus because we go back to being a positive 1, x to the fifth over 5 factorial. All right, again, this pattern is going to repeat, so that's how I knew it was going to be positive. It's either going to be positive 1, 0, or negative 1, and every even term is getting zeroed out. Well, that makes sense because sine of x is an odd function, so we're only keeping the odd degrees. So the next term would be minus, and you can see x to the 7th over 7 factorial plus, let's see if we can get the nth term, what that would look like. Well, notice that the exponent in what we're taking the factorial of are always the same, so that's good. They'll be represented by the same thing, but they must be odd. So one way we could represent that is x to the 2n plus 1. The 2n forces it to be even, adding 1 will force it to always be odd, over 2n plus 1 factorial. That handles the term itself. Now it does need to alternate. So we'll put in a negative 1, and we wanted to start off at a positive. So let's go ahead and put in n. So if we wanted to write this up in summation notation, I'm going to have negative 1 to the I. I'm going to use I because I'm going to use n here. X to the 2i plus 1 over 2i plus 1 factorial. And sorry, not there. That should also be I. N is going to go here because we're looking at the nth degree Taylor polynomial. Now my only question is, where do I want to start I? Well, if I started at 0, that'll give me x to the first over 1 factorial. That checks out, and that'll give me positive. So there is my nth degree Taylor polynomial for sine of x.